Yes, in the last class we discussed about the rule, right? And O. So there are two rules, and O. So this AND rule for what do you call it? We do multiplication, and O rule for plus. So this is actually this is the sequential, right? We apply AND rule for sequence. So finally, it gives us very low chance of getting win in their situation. And the O chance, it's for mutually exclusive events. In that instances, we do actually, this is what it is, union. This is what the this is intersection. O is actually the union, right? And now we discuss one more thing. It's a complement. Complement mean except. For example, here example. So here there are in this trial, a coin has tossed 3 times, and we have get this count of outcomes. We have altogether 8 outcomes. 1, 2, 3, 4, 5, 6, 7, 8 outcomes altogether. And if somebody asks you, right, what is the probability of getting at least one tail, right? What's the probability of getting at least one tail? Here we have one tail, one tail, one tail, right? Tail, 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 tail. This means this is right. This is the event where we are not getting any tail, right? So what we can do is altogether, right? Altogether 8 outcomes, no? Altogether 8 outcomes, but in only one outcome we are not getting the things. So what we have to do, at least obtaining at least one tail, it means we have to take all these values. So when somebody asks what the probability of getting at least one tail, so we know this is 1/8, this is 1/8, 1/8. So there are 7 of 8. So what we have to do is we have to make it plus 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 because it's AND logic. Easy way is what we know that probability of this is 1/8. Rest of them are they're right, so it comes under success. What we can do is rather than doing addition, what we can do, we know that sum of all probabilities equal to 1, right? Sum of all probabilities equal to 1, and probability of this event is 1/8. So we can simply find 7/8. Obtaining at least one head is equal to 7/8. So there are ways. It's a shortcut. It's a shortcut. That's why it says at least one. At least one is a shortcut. The shortcut we may use complement. In Venn diagram, we use the term, for example, this A, except A, or we use this term, right? Except A. Problem, for example, probability of at least one tail in 3 tosses, as we discussed. So out of 8 outcomes, only one outcome will not satisfy this criteria. Only one outcome. So what we can do here, this is what probability, the total probability of the trial is 1. And even A, what's that even A? Even A is probability of at least one tail. Probability of at least one tail is the probability of A. So this is A, right? We want to find this A. And what is this one? Everything else. What is everything else? H, H, H. So only this event without at least one single tail. So that is here. So when we draw this one, how we can write this? Right? H, H, T, and H, T, H, T, H, 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 right? So all these outcomes, all these possible combinations will come under probability A, right? So this is what? This is probability of A complement. So we know that exactly this. So we can easily calculate this one, this area. We can easily calculate this area, right? How we can calculate 1 over, right? 1 over 1 minus A. So we can get 1 minus A is equal what? Everything else. So to find out even A, probability of A, 1 minus A complement, then we can get probability of this. So it's simple. Probability of A equal, what's probability A? Probability of at least obtaining one tail. So that is probability A. We define that, and we know that total probability equal to 1, and we know that only one event H does not have at least one T. So this is not A, probability of not A. So we know the probability of not A is 1 over 8 because of this, only this event, not A. So we know the probability 1/8. So that's 1 minus 1 over 8, we can get easily 7 over 8. Here, backdoor methods, right? It's a backdoor method, simply shortcut. Calculate P, this mean no tails. This is complement, A complement. So that is what? Probability of getting H, that is 1 over 8. Then we subtract from 1 because total probability equal to 1. So the result, this. Clear? Is it clear? Complement?
Yes, sir.
Yeah. So we can write this here. When we show this in a Venn diagram, this diagram shows the union, the green light. This is union, right? Union. And the union, normally we use and, O logic, right? That is plus. And A intersection B, this area, it's a common area, right? It's a common area. It is called what? A intersection B. So this is for AND operation. AND operation, normally what we do, multiplication. And the complement, right? So probability of target, this area is this, and A complement mean, so out of A except A, all other things, everything else represent A complement. This is complement of A. So this understanding, this mind map Venn diagram is very important. When you answer this kind of questions, it should be run in your mind. Next, event relation, right? Event relation. We should understand the intersection versus union. Intersection is this and logic. So even A, when B, this is common. Right? This is common. And union or logic. So this total of this, even A or B, right? This is A and B. This is area, this area, A and B. This area A only, so B only. This area A only. So this is A and B, common area. Right? Here, this area A only, this is B only, A and B. It means total. Union mean the total. A only plus B only plus common area. And general addition theorem. Right? So if the trial is mutually exclusive, we should draw this Venn diagram like this. This is mutually exclusive. Event is mutually exclusive. This is event A, this is event B, mutually exclusive. There is no intersections. That means in one trial, we can get either A or either B. We can't take both. For example, when you toss a coin, either you will get A or B. You can't get same outcome like this. You can't. You never get this outcome. Head, tail. So this is not mutually exclusive. It is wrong. So this area represent what? A and B. In a toss, A and B. It never happens. So this is not mutually exclusive. So this is mutually exclusive. Right here, a trial that is not mutually exclusive. A trial is not mutually exclusive. Here, the general addition theorem. So correcting for overlap. Correcting for overlap. So look at this. The probability of A or B means probability of A union B. So normally is what it represents when we draw in the diagram like this. No, it should come. It should at all the things. Here, when you look at here, this formula, A union B equal probability of A. This area. But here we want to deduct this common area. Why is that? You want to deduct the common area. But at the same time, look at this formula now. Right? It has two parts. One part, A union B, right? A union B. It's O logic. Probability of A and the probability of B. Right? And after that, we deduct probability intersection area, intersection B. Same thing we discussed earlier, but here, see, probability of A union B, right? Same. Probability of A union B, here, probability A plus probability B. Here, we are not deducting anything. We are not deducting probability of A intersection B. Here, we are not considering. So what's the difference? When we use this formula and when we do use this formula, so what's the difference? What's the difference? Did you observe any differences between these two? Any differences? You see here. You see A union B equal probability of A plus probability B. And here probability A probability B minus probability intersection B. What's the reason we deduct the common area? What's the reason of deducting this common area? Any idea from your side? Any understanding? Is it clear? Or do you want explanation with example? Numerical example. Why? But yes. Let us look at. Let us try to understand using an example. And here, example is given. The formula is used to find probability of event A or event B is happening. In maths, we use O. So it's represent union, no? Union. It represents by union symbol. So look at here, the Venn diagram. This is not mutually exclusive. It is not mutually exclusive, but this diagram, this formula, you see, this is mutually exclusive. There's a gap. There's a gap. Since it has no common area. No common area. Look here. A intersection B is equal to 0. Right? That is one logic. But actually, right, for better understanding, we will use one scenario. the formula in case the event is non-mutually exclusive, probability of A union B equal probability of A plus probability of B minus probability of intersection A intersection B. And the summary is what? Union means for this symbol, and intersection is this symbol. Meaning event A happens, or event B happens, or both. So that is exactly meaning. So it covers all area. A intersection B, both events happen at the same time. This is very important. At the same time, no overlap. So there's an overlap, right? There's an overlap. Let us use a dice diagram. So dice example, dice scenario. You roll two six-sided dice, six-face dice, and you define event A. The first die, the score 4. Event B, the second die is 4. So these two events are independent events. These events, both of these events are independent because you roll the die 2 times, or you roll the die 2 times, right? You roll the dice 2 times. So whatever, right? It should be independent. Even A define first row you should exactly 4. Second row you should exactly 4. So shall we put it in their diagram? Assume that the first row is a white die, the second row maybe black die. These are the sample space, right? Sample space. Either the first time you may get 1 1, or 1 2, or 1 3, 1 4, 1 5, like that, or you may get 1 2, 1 3, 1 4, 1 5, 1 6, or other way around, 5 1, right? This is 1 1, 2 1, 3 1, 4 1, 5 1, 6 1. This is 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. And for example, this one 4 5, or 5 4, right? So we can get this kind of things. Altogether there are 36 outcomes. But we want the first, right? In the first row we have to get 4, right? I think it's this one, first row, this, right? And this. Either we can get 1 comma 4, 2 comma 4, 3 comma 4, right? 4 comma 4, 5 comma 4, 6 comma 4. How many in the first row? How many? Not first row. Second row, how many events? How many? 6 times, right? Even A. So actually, this is B, right? This is actually B. Why? Second die, 4 4 4, 4 4 4. So there are 6 outcomes, right? In the second, sorry, here even A, first 1 comma, I write in blue, 4 comma 1, 4 comma 1, 4 comma 2, 4 comma 3, 4 comma 5, 4 comma 6. 1 2 3, 1 2 3 4, right? 4 comma 4. So how many outcomes?
6.
How many? 6 outcomes, right? Altogether, out of 36, how many outcomes we get? A possible outcome, our expected outcome, at least 4, right? Score 4. First die 4, second 4, right? So this is actually first, this is second throw. This is second throw, this is first throw. Now tell me how many expected outcomes. 6 plus 6. 6 plus 6, what?
12.
12. Total 36. And then what's the probability? 1 over 3,
3.
isn't it? 3. But here your answer is wrong. Why? That's a common area, right? The common. This is common item. When you plot this in a Venn diagram, you may draw like this. You may draw like this. This is wrong, and this is wrong, right? Even A, if you define even A, right, in the first row, you got A. You got 4, 1, 4, 4, 3, 4, 5, 4, 6, 4, 4, right? And the B, right, even B, second, right, second you may get B. So second, it's been B, probably B, you get 4 in the second row, or second die. Oh. Here, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then when we draw in this diagram, so 4 comma 4 is a common, no? So it's common for even A, even B. So now you see even A, 6, even B, 6, and the common area, probability of A intersection B is 1, right? 1. Now see, the 6, 12 minus 1, 11 out of 36. So this is actually probability of A and B. Probability of A and B, A union B. Sorry, probability of A or B, right? Probability of A or B. This outcome 4 comma 4 is in both A and B, so it occurs twice, right? It's occurred twice if just added probability of A, probability of B. So here it is. Count the outcomes. Outcome for A, so this is outcomes, 6 outcomes. Outcome for B, so here 6 outcomes, and overlap. So overlap. This is the overlap. Overlap. So notice 4 comma 4 in both sides. So that is one outcome. So apply this formula, then we will get A union B. A probability of getting A or B is 11 over 36. So why do we subtract the overlap? If we simply added 6 plus 6, we would count the result 4 comma 4 twice, subtracting the intersection once. Correct the count, so every outcome is only counted once. Even to make it more clear, write this. So now count this one. Count how many? How many? Without duplication, shall we count? Right? How many? 4. At least 4, right? 4. First row 4 or second row 4. This is first row, no? First row. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So there are 11 outcomes. 11 outcomes. Out of balance, what is balance? Balance, I put red, green. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, right? So 25 plus 11, then 36. If we count it as 12, right? If you count this 2 times, 25 plus 12, 37. But actually, we have totally 36 outcomes only. Clear? Is it clear? Why do we deduct this one? Any doubt? Any questions? Okay. So now you will get this one. So this is the formula, right? Remember, this is the find formula. So before you calculate the probability A or B, we have to draw, right, this diagram, or this way or this way, sorry, this way. If you have this intersection, find, so you have to deduct. If not, no need to deduct. Even if you apply this formula, you will get 0. There is no intersect, no intersection. Right. Now let us use another example, case study. The price problem, the price. A student has a chance for a math prize 44. There is a competition in a school. A student has a chance of getting prize for maths only, right? For prize for maths 44%, and for subject statistic prize, getting chance of getting statistic prize 0.58, 58%, and a chance to win both maths prize and statistic prize is 0.16. Question: find the probability the students receive at least one prize. At least one prize, right? The term is very important. At least one. At least one mean the student may have chance of even. So according to this, the probability of getting prize for maths, or probability of getting prize for statistics, or both. So if we do that, right, in our probabilitical term, statistical term, if we translate this, we can write like this: probability of getting maths 0.44, probability of getting stat price 0.58. The math is here, the maths intersection stat price for, right, the chance of getting prices for both. He will get price for maths, and he will get price for stat. He will get two prices. That is 0.16. Then find probability of maths union statistics. So this is O. So O mean what is that? This is probability of getting math, probability of getting price for statistics. Here 0.44. This is 0.58, and this is 0.16. So what you can do easily, according to the formula, you may get 0.44 plus 0.58 minus 0.16. We have to deduct this common area. Then you can get, yes, you can get 0.86. Right? If you fail, right? If you fail to deduct this part, what happened? You can realize it's wrong. You know that the sum of probability is not equal, right? It cannot more than 1, right? Not more than 1. So the thing is here, probability of maths 0.44, probability of getting is that 0.58. When you take this total, what's the answer? What's the total of these two? What's the sum of these two? What's the total of these two values?
1.2.
1.1, 1.12,
1.0.
1.02. Oh, sorry, 1.02, right? 1.02. So it's wrong. Why? The probability never more than 1. So it can reach 1. This means certainty, right? Certain, no, probability equal to 1 mean 100% sure, certainty. But here, more than 1. So wrong, totally wrong. Logically, it's wrong. Right? In that way also you can realize that we have to deduct this. There is an 80% chance the students win at least one prize. Here, this is written like this. Advanced visualization of popularity diagram. And here, so actually the probability of maths is, we write this 0.44 and here 0.42 and we have common area 0.16, and if we deduct this value from the here, we can get this one and this one and this one. 0.44 minus, sorry, 42 minus 0.16, make it, sorry, 58, no, it's 58, sorry, 58 minus 16, we make it 0.42, right? So when you take the all of these, we can get the probability, total probability, which may be 86. And what's the chance of this? What does it mean here? 0.14, 0.14, what's the meaning? Yeah, yes. What is the meaning of this 0.14? The probability of getting no prizes. Probability of getting no prize. No prize for maths, no prize for stat, no prize for both. So this is what complement of this. This area is a complement of A and B. Complement of A and B. This means A union B complement. The management cheat sheet, so it's a summary. See O, right? When you get O and it is mutually exclusive, the diagram look like this. So in case of O, we can do plus operation. In case, right? In case O with overlap means it is not mutually exclusive. It is not mutually exclusive. We have to add, right? We have to add, but at the same time, we have to subtract the intersection. You have to subtract this section, common section. And see the case of AND, it's an independent, it's an independent, action is multiplying like this. Multiply. And at least one mean the outside area, right? Outside area. If you know the probability of outside area, you can calculate easily of this. Say for example, outside area equal 0.4, then what is the value of this area? What's the value of this area? 0.6. 0.6. So this is what is a complement, outside area. And we can by yourself. What's the probability of getting exactly 2 heads? Exactly 2 heads and 1 tail, right? Exactly 2 heads and 1 tail. What's the probability? The probability of getting exactly 2 heads. So here we can say head, 1 tail, head, tail, and head, tail. So all these 3 are what possible outcomes. So this is a tree diagram. No, out of this, right, right, the the coin toss 3 times. Then these are the outcomes. And the question is at least 2 heads, and 1 tail. So we can't get this. We can take, and we can take, we can't take this, and we can take, we can't take, we can't take, we can't take. So probability of this, and probability of this. How to calculate probability of this? This is what we know, 1 over 2. This is 1 over 2. And this is 1 over 2. This is 1 over 2. And 1 over 2, 1 over 2. So what we do to find the probability of this, what we do, 1 over 2 into 1 over 2 into 1 over 2. This is 1 over 8. And like this also 1 over 8. This is 1 over 8. So the question is exactly 2 heads and 1 tail. Exactly. So we can take this. So if we get this outcome, we also win. If we get this outcome, also we win. For this outcome, also we win. So that O, then we get the probability of getting 3 over 8. Clear? Clear? So this is what? 1 over 8. Clear?
Yes.
Okay, good. Common exam pitfalls. Why? Where? How the students make mistake most frequently. Identity crisis. Confusing. Right? Students are confusing whether it is mutually exclusive or not. Can't happen together. Mutually exclusive mean can't happen together. With independent, don't influence each other. Many students thinks that mutually exclusive and independence are opposite terms. So actually these are two different angles. I explained it last class. Double counting. Sometimes people do count double counting. So forgetting to subtract the intersection, the common area in the union problem, right? Like this. If they add together and if they forget to deduct the common area, no issue because common area is 0, no problem, no impact. But in this case, that's a common area. If they forget to do that, they will get a wrong answer. So therefore, logical understanding is very important. For logical understanding, you should know whether you decide whether it is mutually exclusive or not mutually exclusive, and it is independent or it is non-independent, dependent. The impossible sum, right? Probabilities must sum, right? Always the sum equal to 1. If answer is 1.2, right, you are stop. You are wrong somewhere. Managing the future, a probability does not eliminate risk, but it provides a logic to manage it. So this is about that session, and we will move to the next session. And before that, we will take a small break.